Hello everyone, myself Nasrina, Assistant Professor of School of Pharmaceutical Science USTM. Today I am going to discuss about the suspensions. So let's get started. What is suspension? First of all, you should know about the definition. So suspension is a biphasic liquid dosage form which is heterogeneous in nature. So a pharmaceutical suspension is also called a coarse type of dispersions in which the finely divided solid particles are evenly distributed throughout the mediums, where the particle size ranging from 0.5 to 5 microns. The solid particles here act as a disperse phase and the liquid which act as a vehicle or the solvent. Suspension is divided into core suspensions, pure oral penetrance, and then so before going in details, so let's start with the definition. So let's start the video with the definition of the suspension. So what is suspension? A pharmaceutical suspensions are a biphasic liquid dosage form of medicament in which the solid particle are widely distributed throughout the medium. So here the particle size ranging from 0.5 to 5 micron. Here the solid particles which act as a disperse phase and the liquid vehicle that acts as a continuous phase or solvent. So a suspension is heterogeneous in nature because the solid parts here are insoluble with the solvent. That's why it is called biphasic heterogeneous mixture. So according to the particle size of the dispersed phase, suspension are divided into two categories, coarse suspension and the colloidal suspension. Whereas come to the coarse suspension, where the particle size ranges in between 1 to 100 micron, that is called coarse suspensions. And next one is colloidal suspension, so where the particle size ranges between 1 to 1000 nanometer. Now suspension are meant for oral use, parenteral use, ophthalmic use, and also for external use. Let us understand this phenomenon with the help of this diagram. So here, as you can see here, for suppose this is a phase where we have taken here sugar, we can consider this sugar as a solute or the solid part, because here the solid part act as a disperse phase. So here next is water. So this water will consider act as a liquid vehicle, that is the solvent, and we call it continuous phase. So here, so as we can see here, there is two phase. One is solid phase, another is liquid phase. Solid phase is the sugar and the liquid phase is the water. So now clearly we can see there is a two phase. Now let's mix this solid with the solvent, means the sugar is going to mix with the water. So now next part is C. Now we can see there is a phase where we can see only single phase, that is the solution, because this sugar is soluble with the solvent. So we can see only single phase. From two phase, now we can see only one phase. So that is called monophasic and homogeneous. So if the solute part is soluble with the solvent, that is called solution. Okay, when the solute is soluble with the solvent, that is called solutions. So next we'll see another example. So here, for suppose we have taken here calcium carbonate, or we can take chalk, sand, etc. Next is water as a solvent. So here this part will considered as a solute part, and this one will be the solvent part. Now let's mix this solute with this solvent. So what we can see here, we can see this calcium carbonate is insoluble with the solvent. That means now we can see clearly there is two phase. One is water, another is this solute, means this is insoluble with each other. So we can call it suspensions. So So suspension means biphasic liquid gaseous forms where one phase, that is the solute phase, is insoluble with the solvent. So we call it biphasic systems and the heterogeneous mixtures. Okay. So based on the stability, suspension is of two types. One is flocculated suspension, another is deflocculated suspension. See here, if you see this diagram, this one is called stable suspension, this one is called unstable suspension. So here, why it is called stable suspension? Because here the solute is distributed throughout the dispersion medium, that is the dispersed phase, that means the solute is distributed throughout the dispersion medium, that is why it is called stable suspension. Next to this diagram, it is called unstable suspension. Why it is called unstable suspension? Because we can see here the solute part, it settles at the bottoms of the container. So we can see here separation of two phases. This is the solvent and this is the solute. So separation of two phases means the solute part, it settles at the bottom of the container, and that leads to instability of the suspension. So this is called stable suspension when the solute is widely distributed throughout the dispersion medium or throughout the continuous phase, that is called stable suspension. When the solute is not widely distributed throughout the medium, or it may settle at the bottom of the container, or separation of the two phase, solvent and solute, so that part leads to the instability of suspension. So a pharmaceutical suspension are biphasic liquid gaseous form of medicament in which finely divided solid particles disperse in a liquid medium. So what are the qualities of a good suspension? It should settle slowly and should be readily redispersed on gentle shaking of the container. So what does it mean? Means a good suspension should be settled slowly. So here we can consider the sedimentation part. So the sedimentation rate should be slow, and upon shaking the solute part should be dispersed or redispersed with the solvent. That is called a good qualities of a suspension. It should settle slowly and should be readily redispersed on gentle shaking of the container. Next, the suspension should pour readily and evenly from its container. So while dispensing it to the patient, it should easily come out from the containers. It should be chemically inert. It should not form any chemical incompatibility with the other ingredients or with the containers. It should be chemically inert. It should not form any chemical incompatibilities either with the container or with the chemicals present or ingredients present in the formulations. The suspended particles should not form a hard cake. Here, if the sedimentation takes place, then there will be a formation of hard cake. So there is a point, a hard cake formation should be avoided, or else upon shaking also the cake will not be redispersed, or the solute part will not be redispersed with the solvent. That leads to instability of the suspension. Next, it should have pleasant color, odor, and should be uniformly dispersed. So it should have proper color and it should have proper odor, and it should be uniformly dispersed. Parenteral and ophthalmic suspension should be sterilized. So before using the suspension, where in case of the parenteral use and in case of ophthalmic use, the suspension should be sterilized before its use. Next, advantage of suspensions. Drugs in suspensions have higher rate of bioavailability. Okay, so solution, then suspension, then capsule, then compressed tablets, and coated tablets. So if we form the dosage form in the suspension form, that leads to higher bioavailability. Next, duration and onset of action can be controlled. We can control their durations and onset of actions. Example, protamine, zinc, insulin suspension. They have given the example also with the advantages. Suspension can mask the unpleasant taste of drug. While formulating, we can add the pleasant odors, coloring substances, then sweetening agent to mask the unpleasant taste of the drug. This is an advantage of the suspensions. Example, they have given chloramphenicol palmitate. Suspension are used to improve the chemical stability of certain drugs. So suspension also, if we prepare the suspension in form of certain drugs, they can increases the chemical stability of certain drugs. Example, procaine penicillin G. Next, if there is some advantage, there will be some disadvantage. So disadvantage of suspensions are like physical stability. This is a major problem, major concerns, physical stability. So we have to maintain the stability of suspension by using certain factors. Sedimentation is a major parameters. Compaction can causes problems. So this physical stability and the sedimentation is the major issues which may lead to the instability of the suspensions. So we can consider these terms as a disadvantage of suspensions. It is bulky, so care must be taken during handling and transportations. As it is bulky in nature, so during handling and during transportation, care must be taken. It is difficult to formulate. Yeah, it is difficult to formulate, so care must be taken during formulations. So uniform and accurate dose may not be achieved. Uniform and accurate dose may not be achieved. That is a disadvantage. Next, types of suspensions. So based on the stability of suspension, suspension is of two types. One is flocculated suspension, another is deflocculated suspensions. So let's see the let's understand this phenomenon with the help of this diagram. So flocculated suspension, this one will consider as a flocculated and this one deflocculated. So here period of standing, short period. What does it mean, flocculated and deflocculated? So flocculated suspension means their rate of sedimentation will be high. Here the rate of sedimentation will be high and here the rate of sedimentation will be slow. Why? Because here in the flocculated suspension, flocks, the term itself indicates flock. The particles here itself, it makes a network like structure and that leads to formation of certain flocks. That means their weight will be increases if the particles are aggregating or making the network like structure. That means they are increases their weight and that is the formation of flocks, due to which particles undergo high sedimentations, and that is called flocculated suspension. Where in case of deflocculated suspension, where the particle sizes is very less, so it takes time to sediment at the bottom of the container. So if the question arises, which one is most stable, flocculated or deflocculated suspension, so their answer will be like two types. Where if the suspension is currently prepared, then we can call deflocculated is the stable one. But if for the permanent stability, if we say, then will be the flocculated. Why? Because here till here we have seen the flocculated particles, they used to settle at the bottom of the container. Here the sedimentation rate will be high because of the particle weight increases. Here the rate of sedimentation will be slow because the particle sizes here less decreases. So here once now here particles is in a dispersed conditions, this one they have already settled down, but this flocculated is the most stable form of suspension. Why? Here we have seen they used to make the flocks, that means they are the big particles. So in between the big particles there will always be a void space. Void space means here the khali or the empty space. That means here the particles, due to their high weight, they have mixed flocks, and due to which in between of these particles there will be some empty spaces, that is called void spaces. So the solvent which present here, they can enter to this void space, and upon shaking these particles will be redispersed with the solvent and can be make the stable suspension. But in case of here, as the particle size is less, so they will be settled slowly at the bottom of the container. Once they have settled at the bottom of the container, there will be a formation of hard cake, and where the solvent cannot enter inside the void space, because there will be no void space first of all, so the solution cannot enter, and upon shaking also it is very difficult to disperse with the solvent, so it leads to instability of the suspensions. So here in the flocculated suspension, rate of sedimentation will be high, but it is called a stable suspension because upon shaking the solvent, the solute particle will be soluble with the solvent. But here, due to the increases, due to the formation of hard cake, it is difficult to disperse upon shaking also. So here, but here the sedimentation rate will be slow. So we can say that the most stable pharmaceutical suspension is the flocculated one. So as we have seen in the disadvantages of suspension, stability and the sedimentation is a major concern, so which leads to the instability of the suspension. So here the topics is stability of suspension. So how can we maintain the stability of the suspension? So by maintaining this condition, we can maintain the stability of suspension. That is by using the weighting agent, by using the control flocculations, and by using the structure vehicle. Let's discuss in details about these three factors. So stability of suspensions. As we know, stability is a major concern for the suspension. So how can we maintain the stability of the suspensions? So by using these three factors, one is weighting agent, by using control flocculation, and by using structure vehicle. So let's just discuss in details about these two. So weighting agent. So as we know, if we increases the weight size of the particles, it will increases the weight, so it will lead to the sedimentation. So their sedimentation rate will be high. So we have to control the sedimentation rate by decreasing the size of the particle. But now the thing is, if it decreases the size of the particles will increases their surface tension. So that is also a problem, because there will be a formation of lumps. So we have to avoid these certain things. How can we avoid? We can decrease the size of the particle also, and we can avoid the certain problems associated with this decreasing of the particle size, that is like formation of lumps. We can avoid. How can we avoid these things? By using the weighting as an example is polysorbate 80. This is a surfactant, polysorbate 80. It is called a weighting agent. So we can add this agent, which can decreases the interfacial tensions and also can decreases the rate of the sedimentations. Next one is control flocculations. So this is a method where we used to use the electrolytes such as sodium chloride, where both the charges are present. So by these same charges, particle can maintain redispersity. So where positive will attract the negative particles and the negative will attract the positive particles, but positive there will be a repulsion process, and the negative there will be a repulsion process, where the particles have both the charges. So opposite charges will form the flux and the same charges will make the repulsion. By this way, by maintaining this phenomenon, there will be a redispersibility process. So this is a control flocculation where we can control the flocculation by maintaining the electrolyte. So next is structure vehicle. Structure vehicle means we have to increases the viscosity of the dispersion medium, and we can decrease the rate of sedimentation process. Example, acacia. So acacia is a example for the structure vehicle. So this is a substance where we have to add with the solvent, okay, and this should be compatible with the solvent also. So this, if we add to the solvent, their viscosity will be increases. So we can consider here an example. Take the honey and take water. So place a coin to this two containers. So which one will allow to pass the coin very easily to the bottom of the container? Obviously the water, because of the less viscosity, but the honey will resist the flow because of the viscosity. So here is also the acacia will increases the viscosity of the dispersion medium, by which the particles, they will not allow the particle to settle at the bottom of the container easily. By this way we can maintain the rate of sedimentation, or we can decreases the rate of sedimentation by increasing the viscosity of the dispersion medium. So these three factors is important. By maintaining these three factors, we can stop the stability of suspension, or we can stop the rate of sedimentation process. We can decreases the rate of sedimentation process. That's all about the today's video. Thank you everyone.